Hello and welcome to Patch Math, where today we are going to patch your math knowledge on converting quadratics to vertex form. Now, what you have been given here is a quadratic in standard form. And standard form is good for finding x and y intercepts. However, it is not good for much else as far as graphing goes, maybe making a table. So vertex form gives us our vertex. It'll also give us our axis of symmetry. And here is vertex form. Notice it looks a little bit different. And I also want to say there's more than one way to do this. And I'm going to go with what I believe or what it seems to be is the path of least resistance. So if you've been taught to do this a different way, please don't worry about it. That is also valid. And I'm hoping throughout the years I'll be able to make different videos that show the different ways that you can complete the square. Now, my goal here is to make it as simple as possible. I like all my completing the square to happen on the right-hand side and everything else to be on the left-hand side. And I see automatically that when I complete the square, oh, yeah, the main, I'm not defining completing the square. All right, so I went ahead and added a little bit of information to the whiteboard. Take a moment, pause the video, and read that. So when we convert to vertex form for quadratics, we use completing the square. All right, completing the square. And when you are completing the square, I want you to immediately think, I'm down here, immediately think what constants. That's going to be what, in this case, I'll show you. But what constants can we do to result in a binomial squared? We are focusing in on this binomial squared. All right, this binomial squared. Notice we'll have some constant k on the outside, but we are focusing on creating that binomial squared. Well, if we look at what we have here, we're not going to be able to get a binomial squared when we factor that. So we got to move some things around. The goal is to keep the x squared and then negative 2x on the right-hand side and move the current constant away so we can find a new constant that will allow us, again, what constant will result in a binomial squared when we factor our quadratic, So bear with me one moment. All right, and move that around so we could dive into some completing the square. So our first goal is to clean things up. What we do to one side of the equation, for as long as we do the exact same thing to the other side of the equation, we can do it. So I do not like this -5 constant I have here. I want to move it to the left-hand side. The opposite of subtracting 5 is adding 5. That cancels out. And now over here we have 5 plus y or y plus 5. And I'm just going to write it as y plus 5. Now I'm going to treat that left-hand side like it's just there hanging out. I'm going to write it in green so that way my attention is not drawn to it. Now what we have here, this x squared minus 2x. The goal, all right, is on this side to find some constant C, and as what we do to one side, we must do the exact same thing to the other. So some constant C, and I need to move this over because technically, C placement technically does matter. All right, some constant C. Well, what's the definition of C? And if you go online, you're going to see all this information about completing the square, and there's so many different ways to do it. It's just confusing, all right? So for this instance, we're going to look at our C. C, completing the square, is our B. And our B in this case is that -2 over 2 all square. That parentheses does matter. We'll make or break you on this. All square. Notice my number one fault as a teacher is I am disorganized on the whiteboard. Let's move that over and out of the way. So we have our C here. So our B comes from standard form. Now notice standard form, we have our ax squared plus b, ax squared plus b, ax squared plus bx plus a different C. I'm not going to write the rest of that out. So plus some other C. The reason why I'm not writing out C is because the C that we have here is going to be different than the C in standard form. When we look here, our B happens to be -2. We're going to take that -2 and we're going to put it in for our numerator. -2 over 2 is 1. 2 over 2 is 1. Now, I'm going to write this out because the number inside your parentheses is important. Hold on to it. And then we'll find that negative 1 squared. Well, that's just 1. What we do to one side, we must do the exact same thing to the other. And then we bring everything on down. That c is equal to 1. This y plus 5, you're just going to come on down and join it. All right, and the rest comes on down and join it. What we do to one side, we must do the exact same thing to the other. Now, I got a lot of color coding here, and that might be making things confusing. Bear with me just one moment while we finish this up. Now we're going to simplify this left-hand side. And when we simplify, we're going to do the operations as they are given. We have y plus 5 plus 1. Well, that's y plus 6. And over here, we have x squared minus 2x plus 1. The goal was when we factor that quadratic, so this quadratic right here, when we factor this quadratic right here, we want to get two binomials multiplied by each other that are the same. So a binomial squared. Well, how do we do that? Well, if you've been taught the AC method, if you're this far in Algebra 2, or in an honors Algebra 1 class, if you are this far, you know the AC method. When our A is 1, we have a pattern. And the cool thing is, when you're completing the square, your C, or not C, sorry, I said the wrong variable there. Your constant is on the inside of the binomial is going to be what's on the inside of the parentheses for your C. Watch what I mean whenever we FOIL. So I'm going to write this in pink so you can see where I pulled it from. I got this from the inside of that b over 2, b over 2 on the inside of our, what c equals b over 2 squared, but the inside of that parentheses, that's negative 1. That's always going to be the constant in your binomials here. Watch what happens. You have x minus 1, we FOIL, first, outer, inner, last, x squared, minus 1x, minus 1x. Well, that's negative 2x. Negative 1 times negative 1 is positive 1. And there you have it. We have x squared minus 2x plus 1 written as a binomial times the exact same binomial. In other words, a binomial squared. And if you zoom on out, when we convert to vertex form, we must complete the square. And when we are completing the square, think what constant, that's a number of no variable attached by multiplication, will result in a binomial squared. Well, what constant here will result in a binomial squared? That is that positive 1, and our binomial squared is x minus 1 squared. Now the thing is, what do we do with this other side? Because we can't just leave it as y plus 6. We can't easily generate a table or find information from this. Well, we solve for y to make it where we plug in our input, our x, and find our output y easily because the y is isolated. So we isolate the y. And isolating the y in this case is meaning leaving everything alone. And then what you do to one side of the equation, for as long as you do the exact same thing to the other side of the equation, you can do it, all right? So this 6 is being added on. The opposite of addition is subtraction. So if we want to get that to go away, to cancel out, for that to just be y, we're going to minus 6. Now we're going to minus that 6 from both sides. And when we minus 6 here, it just gets tacked on to the outside. We're going to leave that parentheses squared because PEMDAS says, hey, parentheses and exponents must come first. We can't simplify that down anymore. So that minus 6 is on the outside. And there you have it. That is, it's kind of crunched up there. The vertex form of this quadratic is y equals x minus 1 all squared minus 6. This problem only asked us to write the use the information provided to write the vertex form of the equation of the problem. It did not actually ask us to find the vertex. However, I wouldn't be teaching this topic properly if I did not give you the opportunity to find what that vertex is, because it's just right there. Notice in the formula, given in the formula, there is a negative in front of that h. So when we plug any number into the formula, any vertex, it's going to take the h. So like we had like 3, 1. And you put that in there. That's -3. Well, what was the h that got plugged in? It was 3. In this scenario, whenever we are pulling our vertex out, we got to think a negative already existed in the formula. So whatever our h is actually going to be the opposite sign of the constant inside of our binomial. So our hk in this instance, hk is equal to +1, because we would have to plug a +1 in there for that to be x minus 1 because of the negative in the formula, -6. That is the vertex of this parabola, 1, -6. Now, let's say you were just graphing this thing and you wanted to graph the rest. There's more than one method. You could generate a table. You could go back up to your standard form and find your x and y intercepts. That's what I recommend. All right. You could also use parent function transformations, especially if you're in pre-cal, you'll be learning that. That is my least favorite. I do not like parent functions. I prefer to convert to vertex form and find our x and y intercepts from the standard form any day. But that's just a little bit of extra where this topic can go. And there you have it. Your math knowledge has just been excuse me. All right. And there you have it. Your math knowledge has just been patched over how to convert quadratics to vertex form using completing the square. Thank you so much for your time.